All right, so I want to go over the solutions for some of those AP Classroom FRQs that you had. We didn't have time to get to them in class last week. Maybe we'll have time to get to them this week since we have longer classes. I don't know. But this is 6A, and this is the first question. There were actually two questions on this one, I think. They gave us a table of values. They told us that something was leaking. That was gallons per hour and T's and hours. They also said the word twice differentiable. That may be important at some point. Don't know. Let's find out. So, part A, big thing to notice, they're saying approximate the derivative. That means approximate the slope. It's supposed to be an instantaneous rate of change, but if you're approximating it, we do that by taking the best slope we can. Okay. Part D is actually trying to figure out exactly what does this summation represent. Now you have to go a long way back to chapter 4 to think about these summations, and we didn't spend much time on this, but I did mention they have been having a habit of throwing these on AP exams. And here's what you do. You know this has to somehow represent a function times a D something or another. Well, should I take a wild guess and say maybe there's going to be a DT here? But if you can remember what that represents, this is just a way of saying what is the height of each rectangle times the width. DT equals the width. So there's a couple things to remember. The width of each individual rectangle when we're looking at this is B minus A. When you're looking, from A to B. That gives you the total width divided by the number of rectangles we're using. In this case, what do we see here? We see that the width of each rectangle here is going to be 1 over n. That means B minus A is 1. The total width of this is going to be 1. So whatever we have for A, the upper limit is going to be A plus 1. Then there's a few signs here. This must represent the function, which is the height. These things always are height times width. How you get the area of a rectangle. So it looks like my function here is some kind of R function. That's not entirely surprising either. You get a point for that maybe. But here's the one thing I want you to remember. One, they're throwing out K just to confuse you, but this first number tells you the starting point. We're starting at 1/2. And this just means, and then go to the next rectangle and find the next height. And when you add another number, you go to the next rectangle and find another height. Essentially,